Quick intro. Regression testing is performed after new feature testing. During regression testing, we check to see if changes made in the software have broken things that used to work before those changes. In other words, during regression testing, we are looking for regressions, new bugs in previously working parts of software. Let's say that we've written 5 test suites for new feature testing of Release 6.0. Also, we have 21 test suites that we've written and executed for previous releases. Each of those 21 test suites is a potential candidate for regression testing. The problem is that we simply don't have enough time to execute all 21 test suites because release schedule for 6.0 allows us only 2 weeks for regression testing, while the execution of 21 test suites takes 2 months. This brings up 2 questions. 1. How can we select several test suites out of 21 to do proper regression testing? 2. What is the solution for regression testing in the long run? After Release 6.0 is pushed to prod, our collection for regression testing grows to 26 test suites. After Release 7.0, we'll have more test suites, and so on. Think about the snowball effect. Thus, we have 2 topics here. 1. How to select test suites for regression testing. 2. How to resolve the main challenge of regression testing, a contradiction between our limited resources, mostly people and time, and the ever-growing number of test suites. How to select test suites for regression testing? It would really help us if we had an answer to this question. What parts of the software can most easily get broken, and hence should be tested for regressions? Alas, the answer is not easy because software can really get complex and have a lot of interdependencies. It's often difficult even for a programmer to know how a change in one part of the software will echo in its other parts. And what's even worse, the programmers sometimes change software without even trying to figure out if their changes will break something. Example: ShareLane programmer Billy writes some new functionality for the shopping cart. In the process of programming, he modifies the Python function getBookInfo so it returns a data type list instead of dictionary. He does some shopping cart testing on his sandbox, things look good, and then checks in his code into CVS. After the new build is pushed to the testing environment, the tester does new feature testing. By the way, the testing environment can also be called staging environment or just staging. After new feature testing is complete, regression testing starts, and the tester discovers that checkout functionality is completely broken. A P1 bug is filed. The root cause of the bug is that the file checkout.py also uses function getBookInfo and treats its output as a dictionary, not a list. In other words, we have a regression in checkout functionality. Brain positioning? The important thing to understand about regressions in software is that if developer modifies functionality A, he can break functionality B, and that functionality B might be related or unrelated to functionality A. Here is our approach to single out 4 groups of test suites for regression testing. The first group must contain test suites that check the parts of software that were changed. Rationale: a programmer is most likely to mess up the code of the feature that he is changing. Example: if the programmer modifies, deletes something in the shopping cart, we know that the shopping cart is affected. So, for the new feature testing, we'll execute new test cases that were written for new changes in the shopping cart. For regression testing, we'll select the legacy test suites that test the shopping cart. The second group must contain test suites that check parts of software that may somehow depend on the changed parts of software. Rationale: while changing feature A, a developer can break a piece of code that feature B depends on. Brain positioning: if developer changes a function that might be called by several parts of the software, he should be really careful not to change the existing logic because those other parts of the software depend on it. If a change in logic is expected, the developer must do a deep dive into the code to see which related parts of the software might be affected by the change. The third group must contain test suites for core functionalities. Rationale? If checkout does not fall into first or second group, we still must test it because checkout is essential to the business of the online store. The fourth group includes test suites that don't belong to groups 1, 2, and 3. As a rule, group 4 includes the majority of test suites we have. Rationale? We should test group 4 because, as we know, a change in one part of the software can often break other seemingly unrelated parts of the software. As you can see, if we execute test cases from groups 1 to 4 inclusively, we'll execute all of our test cases, and that's just usually impossible. Resolving the main challenge of regression testing. Here is the main challenge of regression testing. How can we do proper regression testing if our resources are limited, but the number of test cases is ever growing? These are the ways to solve that challenge. 1. Prioritization of test suites and test cases. 2. Test suite optimization. 3. New hires or outsourcing. 4. Communication. 5. Spreading the execution of legacy test suites among several releases. 6. Test automation. 1. Prioritization of test suites and test cases. The prioritization of test suites and test cases is the cheapest and, in many cases, the most effective solution to resolve the challenge. Test case management systems allow us to select test suites or test cases based on their priority. Also, we can see average execution time for each test suite or a test case. Hence, we can run only high-priority test suites or test cases and plan our testing knowing average execution time for them. By the way, we can use the verbs run and execute interchangeably. Ideally, we should run the whole legacy test suites for regression testing, but in reality, we often don't have time for it even if we choose P1 test suites only. So, it makes sense to plan some combo when we run the whole test suites and selected test cases. Brain positioning. If we use test suite and test case priorities as the criteria for test suite and test case selection for regression testing, we should keep those priorities up to date. The test suite or test case priority must be changed, for example, when a tested feature loses its importance or, on the contrary, becomes more important. But the real power of prioritization comes to us if we take into consideration not only test suite or test case priority, but also to which of 4 groups that test case or test suite belongs. We should always include into regression testing the selected test suites and test cases that belong to groups 1 to 3 inclusively. Groups 1 to 3 inclusively are equally important for regression testing. Group 4 has lower priority, but it should also be tested. We usually spread execution of Group 4 test cases among several releases. 2. Test suite optimization. Many old test cases can be optimized in 2 ways: a reduction in the number of test cases and/or simplification of the test case execution. From point A, very often it makes sense to review test cases that were written some time ago to see if they make any sense today. For example, some features can be deprecated, or maybe the test case is a duplicate of another test case. In some cases, it makes sense to retire whole test suites. For point B, some test cases can be simplified because new helper tools are written. An example of a helper tool is the account creator that we use at ShareLane. 3. New hires or outsourcing. In some cases, this makes sense. In some cases, it doesn't. To hire new testers or to outsource testing is the most linear way to resolve the challenge. We know of both success stories and failure stories. There is no universal advice here. It all depends on the company and its type of business. 4. Communication. Ask developers who work on features for specific release. What part of the software could have been impacted and where are regressions likely to appear? Where regressions are not likely to appear. In both cases, they'll give you an educated guess. This is a very practical approach. 5. Spreading the execution of legacy test suites among several releases. This approach allows us to test parts of software that we didn't touch while executing Group 1, 2, and 3 test suites. We can plan to execute all existing test cases within a certain period of time, for example, within 6 months. So, during regression testing for each major release, we run several test suites or test cases from Group 4. To reduce the number of test suites and test cases, we can choose to run only P1s. 6. Test automation. This is one of the most complex and controversial topics in software testing, so we'll spend 3 lessons on the subject. You will not learn any particular automation tool, but you'll get deep knowledge that will serve you well, whether you'll do QA automation in the future or not. When regression testing stops, there are 2 main factors here: the deadline set for regression testing completion, the test cases to execute for regression testing. The challenge is to execute all the test cases that we decided to execute for regression testing before or at the deadline set for the completion of regression testing. In many cases, this involves overtime work. Brain positioning. Overtime work is a part of our profession, so it shouldn't come as a surprise to you if you have to work more than 8 hours a day to complete whatever you need to do. For example, the execution of a particular test suite. The most successful testers are those who don't count hours at the office, but go above and beyond to do an excellent job. In some cases, an excellent job requires long hours. Brain positioning. If you don't have enough time to execute all test cases planned for regression testing, you should communicate that to your manager ASAP. Don't be silent if you are blocked or don't have enough time to do a quality job. There is always a solution. Test cases can be rearranged among the team members or dropped from execution. In any case, always let your manager know if you cannot do your work according to the planned schedule. We recommend putting several days between the deadline for completion of regression testing for a major release and the go, no-go meeting. That time can be spent to fix and verify bugs that haven't been fixed or verified during regression testing, and to do acceptance testing, also called certification testing. Of course, all critical issues that may delay release should be escalated ASAP. Eventually, we get together for the go, no-go meeting to decide whether we want to release or not. If we don't want to release, then we must resolve the issues that prevent us from releasing, do another acceptance test, and get together for the go, no-go meeting again, and so on until we do our release. Lesson recap. 1. During regression testing, we are looking for regressions, new bugs in previously working functionalities. 2. Every valid test case is a potential candidate for regression testing. 3. It's often difficult even for a programmer to know how a change in one part of the software will affect other parts, and what's even worse, the programmers sometimes change software without even trying to figure out if their changes will break something. 4. The important thing to understand about regressions in software is that if developer modifies functionality A, he can break functionality B, and that functionality B might be related or unrelated to functionality A. 5. The testing environment can also be called staging environment or just staging. 6. The first group of test suites for regression must contain the test suites checking legacy features that are directly affected by a change in the software. 7. The second group of test suites for regression must contain the test suites checking legacy features that may somehow depend on the changed features. 8. The third group must contain test suites for core functionalities. 9. The fourth group includes test suites that don't belong to groups 1, 2, and 3. 10. We can use the verbs run and execute interchangeably when we talk about test cases and test suites. 11. Below are the ways to settle the contradiction between our limited resources and the ever-growing number of test suites. A. Prioritization of test suites and test cases. B. Test suite optimization. C. New hires or outsourcing. D. Communication. E. Spreading the execution of legacy test suites among several releases. F. Test automation. 12. Prioritization of test suites and test cases is the most inexpensive and often the most effective way to resolve the challenge of limited resources and a large number of test suites for regression testing. 13. There are two things that affect the end of regression testing: the deadline set for completion of regression testing, the test cases that we have decided to execute for regression testing. 14. The challenge is to execute all test cases that we have decided to execute for regression testing before or at the deadline set for the completion of regression testing. 15. The decision about whether to release or not is made at the go, no-go meeting.